Okay guys, so we will be talking about neural network today. The material includes your class note and partly Bishop chapter 3. Now, as you can see here, before I will just show you because this is the first time this is the first lecture in this new learning environment. As you can see, the class notes is available here and you have your slides also. Okay, so the other new thing that is coming from this week, I've created a new forum for you for this week. So every week you will be seeing a new forum here. So you can put your own question. If you have any clarification required, you can add your question in this discussion forum. If I just click, you can create your own thread. So you're welcome to participate in this discussion forum, and I and any of my TAs will be as prompt as possible to answer all your queries. But with that said, I would also suggest you to check the questions for which the answers have already been given before you add your questions. Okay. So now we will be talking about. We will come back to our discussion on neural network. These are some motivating example applications that neural network have been successfully adopted in. So as you can see, with neural network, you can actually predict the next move of very complicated games like AlphaGo or chess in an intelligent manner. The other type of example, which is the third one that you can see here, is an example of localization and segmentation, where the task is not to only predict the, or rather, predict the content of the image, which means it is not enough to say whether there is a cat or dog. You are also required to identify the exact location of those objects. The fourth one, I guess it's known to everybody. Deep learning based model, which is nothing but a huge neural network, has also shown very promising performance in terms of generating synthetic images. So these are some good examples to motivate you to study neural network. So now, as of now, we have already learned about regression and classification that comprised of linear combinations of different feature attributes. We also learned SVM. Now, one of the unique advantages of using SVM as a learning model was we could actually introduce non-linearity within the learned model, which was very handy for our various of our tasks because we could approximate the high dimension non-linear data characteristics. Now, what is neural network? Neural network comes right in this juncture where it shows significantly more adaptability in designing a more discriminative nonlinear classifier, but that also needs to learn a number of additional parameters and efficient learning strategy. Now, why are we so bothered about efficiency here? Because now you have a more complicated learning architecture. You have multiple more additional parameters. So all that do not come free of cost. You have to remember that learning all those additional parameters will be expensive. Therefore, one of our primary challenges here is to propose an efficient learning strategy. Right? Now, what is so special about neural network? Since its introduction, one of the biggest motivation to learn neural network was to try to simulate the human brain in the computer. Therefore, before we start talking about neural network, artificial neural network, first we need to understand what is human brain, because that's what we are going to incorporate within our learning architecture. We are going to build artificial neural network. So let's understand what is a human brain. A human brain has about 10 to the power 11 neurons, each of which connects with about 10 to the power 4 other neighboring neurons. Now, a brain neuron is a cell with two significant pieces. One is dendrite, which can receive information in terms of impulse. So, this is the dendrite, which captures impulse information from its neighboring neuron, and this is the other component, which is axon, by which any processed information, the main processing of information happens here within the cell body, but after the information is processed information can be passed to all its neighboring neurons by following the axon. So you have dendrite, which receives impulse information from its neighboring neurons. You have axon, which enables you to communicate the processed information to the other neighboring neurons, right? Now, at any moment, every neuron is always receiving some information, but not necessarily it processes all information, right? So when does it get to process the information or gets excited about passing this information to its neighboring neuron? When it gets sufficiently excited. What do you mean by sufficiently excited? So what happens here is, by using all these dendrites, information are received within the cell body. All these dendrites all capture some information. They receive some information from the neighboring neurons, and all of them gets accumulated within the cell body. Now, after being accumulated, they are processed. How are they getting processed? And what is our understanding about this processing? That we will be talking about little later. But once this entire set of information which get aggregated here and they get processed within the cell body, if the total aggregated information which is processed here within the cell body is sufficiently high, then these neuron gets excited and the corresponding information gets to pass via its axon to its all neighboring neuron. Now all this information goes to another neuron. Suppose you have another neuron here. Now here also, for this neuron also the same story repeats. For this neuron also you have all these dendrites, which is each of these dendrites receiving information from multiple directions, and if these information are, when aggregated within the cell body, is sufficiently high, then again this neuron gets excited and the information gets to pass to neighboring neuron. So essentially, this is how the information gets propagated from one neuron to the other. Okay? Now, with that said, once again I want to emphasize, nobody knows what exactly happens within human brain, right? But this is what our understanding about what the brain does, what human brain does in terms of processing information. And that's what we want to incorporate within our neuron. So the next thing that we are going to talk about is how do you implement this understanding about human brain computation within an artificial neural network. The computational model of a neuron looks like this, where again you have similar set of components. One is axon, from which the neuron gets information, and this is the synaptic strength. This weight is the synaptic strength. So each of its synapses has accompanying weight. Any information which is received by this dendrite, any information that gets received by this dendrite is multiplied by corresponding synaptic strength and then gets added here within the cell body. So essentially, all the signals that travel along the axons interact multiplicatively with the dendrites of the other neuron based on the synaptic strength at that synapse. Therefore, for any information, suppose x0 is one information, x1 is another information, x2 is another information. So all these informations first get multiplied by its corresponding synaptic strength and then gets added within the cell body. Okay. The resulting output is computed here. But whatever the resulting output, which is aggregated output, I would say, which is computed here, is not communicated as is. It is then non-linearly activated by the corresponding activation function, and what the neuron communicates to its neighboring neuron is not just summation of wixi plus b, but f of summation of wixi plus b, which means all the information this neuron receives via its multiple dendrites, all of them gets multiplied by its corresponding synaptic strength, wi's. They get aggregated within the cell body and then non-linearly activated by its corresponding activation function, and the resulting output is something like this. Okay, so that's what is our basic mathematical model of an artificial neural network unit, which means the mathematical model of each neuron. When you are going to discuss about neural network, that will be consisting of multiple more such basic neurons. So this is the basic unit of our neural network that we are going to talk about in the next lecture.